Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking Tableau for sponsoring today's event. Tableau is an integral supporter of the Data Science Central community. We're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including HPE Vertica, Alteryx, Dell Statistica, IBM, Teradata, and Exaptive, to name just a few. Now, past webinars are available on demand at datasciencecentral.com. And if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. So today's webinar is entitled A Natural Language Processing Approach to Data Exploration, to be presented by Tableau. Now, before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have two presenters that I'll introduce in just a minute. There'll be a 10 to 15 minute Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation. Now, we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Now, I'm very pleased to introduce today's speakers, Vidya Setlur and Melanie Tory of Tableau. Now, Vidya is a research scientist at Tableau and works in the Palo Alto office. Previously, she worked as a principal research scientist at the Nokia Research Center for 7 years. She earned her doctorate in computer graphics in 2005 at Northwestern University. Her research interests lie in the intersection of natural language processing and computer graphics in the area of content retargeting and iconography. Now, Melanie is a senior research scientist focusing on interactive visual data analysis. Her research explores techniques and tools to help people analyze data more effectively. Now, before joining Tableau, Melanie was an associate professor in visualization at the University of Victoria. She earned her PhD in computer science from Simon Fraser University and her Bachelor of Science from the University of British Columbia. Melanie is an active member of the visualization research community. She is associate editor of the IEEE Computer Graphics and Applications Group and has served as the papers co-chair for the IEEE Information Visualization and ACM Interactive Tabletops and Surfaces conferences. Well, Vidya, Melanie, thanks for being with us today. We're looking forward to your presentation. Now, what if you could directly ask questions of your data and the software could respond with a selection of a filter, a selection, or a new visualization? You know, in today's DSC webinar, the Tableau Research team explains natural language queries and how they are already helping you visualize your data. Today's presentation includes an introduction to natural language processing, examples of how NLP is already being used in Tableau's geocoding and map search, and a demonstration of some research prototypes that you might see in the not-too-distant future. So please participate in today's discussion and tell us what things you'd want to say or ask of your visualization. So Vidya, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thanks, Bill. All right, so Melanie and I are very excited to have you at our webinar titled An NLP Approach to Data Exploration. And Bill already introduced us, and I've been at Tableau for a little over 4 years and been doing a lot of work in this space and figuring out how natural language can help people see and understand their data. Melanie?
For me, I've been at Tableau for about 1.5 years, where I'm trying to help understand how we can improve the workflow with visual analysis. And in my spare time, I love music, and so does my dog. Vidya?
So we have 3 items in our agenda. First, I will introduce the concept of semantics and natural language processing, followed by a research prototype titled Eviza that we've been developing here in our research group. I will highlight all the features of that prototype, and Melanie will wrap up with an evaluation and future directions. So let's talk about semantics and what NLP is. So language is a tool used to convey information and meaning. It exists all around us in print, words, on the slide, books, maps, signage, and so forth. And as humans, we are particularly skilled at understanding and conveying our thoughts through language. In addition, we tend to use and read our physical bodies through gesturing and voice intonation to further understand language. In addition, we constantly seek meaning in our lives. This is for things that make sense and things that we care about. But meaning is rather an abstract concept, and semantics is a way of expressing that meaning. So in practice, statistical graphics is rather abstract. Here is a graph in log scale showing the relationship between brain and body mass for various animals. Now, if we think about applying semantics to express the meaning of this graph, we can use icons that are semantically connected to each of these animals, and this graph immediately becomes more meaningful, hence more analytically useful. The problem is that we as humans are better than computers in understanding and seeing this meaning, and it's really hard for a computer to figure out the intent of what the user is communicating. This is where the field of natural language processing comes into play. It's an intersection of computer science and linguistics to help computers understand meaning through some defined semantic structure of information. So why is NLP powerful? Let's see some examples. Many of us are familiar with email. This is an example of Google's inbox. Certain actions such as an RSVP or confirming a subscription or tracking a package can be accessed directly through specific actions that are tied to the content of the email. Further, NLP is used to teach inbox to recognize to-dos in your inbox, like a dinner tonight. And many of us are familiar with all forms of web search. So if I'm traveling to New York, I could say New York, things to, and the system will prompt me with stuff to do, eat, see. In addition, I can go to Facebook and find out who lives in New York from my giant relationship graph of friends. And we pretty much use voice on our phone, like Siri, for practically everything. At the other end of the spectrum, we have Watson, an artificially intelligent computer system developed by IBM, capable of answering questions posed in natural language. The computer system was specifically developed to answer questions on the quiz show Jeopardy, and you can see here that the computer is clearly doing much better than the humans. But despite all these advances in NLP technology, understanding language is still a hard problem for a machine. Take the example Caterpillar. Is it the Caterpillar company that makes construction equipment, or the creepy crawly kind? A slight modification to the search disambiguates the context, and I can get more expected results if I'm looking for the creepy crawly kind, where I change caterpillar to caterpillars. Similarly, how does a machine understand the sentence, get the cat with the gloves? You get various images that are semantically different from one another. So how many of you like this second choice better? That's my personal favorite. Revisiting grammar school for a bit. In the first case, with the gloves is a separate prepositional phrase, so it means get the cat using your gloves. In the second case, with the gloves is part of the noun phrase, so it means get the cat that is wearing gloves. Subtle difference in meaning, but totally different results. So if I ask you to enter a question that you would like to ask your data, how many of you know what to ask? It's pretty hard, right, with an empty search bar? So let's add some context here. What if I showed you a map of earthquakes in the United States showing the location and magnitude of these earthquakes? Since I live in California and earthquakes are a matter of concern for me, I could perhaps ask a question, find large earthquakes near California. The Viz would then update to show me a response to my question as shown here. So the first point I'd like to make is that we as people do not converse with data starting from a blank slate. We rely on context to spark our curiosity. There have been several natural language interfaces for data analysis where natural language is used as a modality for interacting with data and performing analytics. Each of these systems listed here is interesting but has fundamental limitations. Most return a minimally interactive visualization in response to the queries, meaning the question must be of a certain type where there is a single exact answer rather than one where there are a range of relevant and useful ways to answer. Many also require experts to perform modeling before these systems are effective. All these systems tend to treat natural language as a shiny magic box existing all by itself. But that's not the way we typically go about doing visual analysis. Visual analysis is a cycle rather than a linear flow of data. The person is having a conversation with their visualization back and forth between the person and the system. And these are ideas that we can draw from natural language that can help augment this visual analysis process. So here at Tableau, we try to do things a bit differently. We emphasize the analytical flow of a user exploring a visualization. So instead of focusing on generating a new visualization, our research primarily explores interaction with an existing visualization or dashboard. Our research focuses on techniques for enhancing the expressibility of how these questions can be asked. And we introduce this through a research prototype called Eviza. So now I will pause and I will move over to demonstrate the prototype. All right, so this is a map of earthquakes in the United States, and I can begin by asking a question about the data. Show me the large earthquakes. The visualization updates showing earthquakes of a certain magnitude. Let me scroll down. So the demo shows earthquakes of a certain magnitude of 5 and more. And I can continue by saying, show me large earthquakes near California. And the system will update by zooming into California and showing me large earthquakes over there. And I can ask a follow-up question by saying, how about near Texas? So there were no marks selected because my magnitude was set to 5 and more, and I can reduce it to 4, and the map updates to show me earthquakes of 4 and greater. I could ask another question. How about near Nebraska? The system remembers that I modified my slider to be 4 and greater, and it updates the map showing earthquakes of magnitude 4 and greater in Nebraska. So here I'd like to pause and explain this feature of Pragmatics that we support in the system. So my previous queries were about large earthquakes near California and large earthquakes in general. So when I pivoted from that original question and asked about how about near Texas or how about near Nebraska, the system remembers what I asked and saves that setting and basically tries to understand the question where I'm referring to large earthquakes near Texas or large earthquakes near Nebraska. Moving on to another example. This is a line chart showing temperatures in New Zealand, and I can start by asking a question, temperatures in January. So the system updates that to show me temperatures in January. I could also say temperatures near January. And the system basically expresses this fuzzy ambiguity near as an ambiguity widget as shown here. And it pads it to be about a month before and around January and after. And I can go and update this to a different month, say March, and the system will update that. In addition to supporting ambiguity through these widgets, we can also ask questions around temporal ranges. So I could say in spring. And since these temperatures are from New Zealand, spring is mapped to be that from the southern hemisphere. So it updates the seasonal range to that of the southern hemisphere. And I could say in fall. Or I could ask, show me the min, max, and average. And since I live in the United States, I don't quite understand the concept of Celsius, so I could say in Fahrenheit. And it will convert Celsius into Fahrenheit even though those values are not explicitly part of the data set. Moving on to another example, a bar chart showing GDP per capita for various countries. And I could start by saying, find GDP between. And notice here that this autocompletion shows a numerical range for GDP because the system recognizes GDP to be a numerical attribute in the data. And I can complete that by specifying a range. And it'll highlight the appropriate bars. One thing that I'd like to point out is even though the data attribute is GDP per capita, even though I specify GDP, the system will do a fuzzy string match to match GDP to GDP per capita. And I could say sort descending. And it'll sort the bars. I could say color by region. And it'll apply a categorical color palette that is color-coded by these 3 regions. I could say color by population. And it'll apply a quantitative color palette by population. In addition to supporting questions in single vises, we can also ask questions in a dashboard. So this is a dashboard of housing data in Seattle. And I can begin by saying, show me houses near Ballard. And it updates the visualization and shows an ambiguity widget for this fuzzy spatial distance near to be 2 miles around the vicinity of Ballard, and the other two charts update as well. The system supports these compound queries where I can chain other types of attributes and conditions to the original query. So show me houses near Ballard under 600K, and the visualization would update. In addition to supporting queries that reference the data attributes in the visualizations, we can also ask questions that refer to the visualization properties. So I could say, what are the values of the big circles? And it shows me the larger square footage marks in the map. And the system knows the types of encodings that are in each of these visits. So the map has a circular encoding of marks, and the map would respond to this query by showing the top n percentage of square footage homes in the map, updating the other visualizations accordingly. So in addition to asking questions within a pre-authored visualization and dashboard, there is no reason why we can't start off from a visualization and create additional ones. So if I start off with a subset of the dashboard showing houses in the area around Seattle, I could say average price by neighborhood. And the system recognizes that the response to this question cannot be answered effectively in a map, so it displays a bar chart with those two attributes of average price and neighborhood. I could ask another question, average price over time, and the system will display a line chart of average prices over a certain time period. And I do know that I have certain data attributes in home type, so I could say by home type. And the single line chart will split into 3 home types: condo, single-family houses, and townhomes. So in effect, I created a dashboard starting from a single viz based on the types of questions I asked. At this point, I will stop the demo and continue with the presentation. All right, so just going through the overview of the system, I'll be talking about each of these components in a little bit more detail. The first component is the parser that parses the input query in order to make sense of it. The interface to Eviza is specified by a grammar that is applied algorithmically to provide a structural description of the input query. While pre-specified rules are loaded ahead of time, these rules are further refined by data attributes in the current visualization. For example, a rule, large value in place, is refined to expect earthquakes and a place from the data set in the map. A main challenge with natural language systems is communicating to the user the types of inputs possible. Eviza has an autocompletion component for text input that uses these template rules from the grammar to immediately indicate to the user the possible expressions and values. As we analyze real-life data, the enrichment of the data's meaning with additional semantics helps with the expressiveness of the natural language interaction. The Semantics module augments data with additional semantics and units such as time, space, and entities from existing knowledge bases such as Wolfram Alpha and WordNet. So here, for example, large is one of the tokens in the input query, but the problem is that large is not encoded as part of the map. So how do we interpret large and come up with a mapping to an attribute in the viz? Here we find that there is a strong semantic association between large from the query and magnitude encoded in the map using the semantic similarity measure, based on word senses in WordNet. Further, we can associate a range of magnitude values to the term large based on the description of the magnitude shown here in Wolfram Alpha. This leads to showing earthquakes of magnitude 5 and greater around California. Other semantic enrichment includes basic unit types such as time hierarchies, temperature, currencies, and quantitative units. So I can have Fahrenheit, which is recognized to be units, and fall, which is a seasonal range based on the hemisphere from where the data belongs to. And it will update the visualization accordingly, showing ambiguity widgets at the bottom. One of Eviza's goals is to support analytical flow by enabling the user to have a conversation with the visualization. Conversation frequently consists of a series of related utterances, often referring to past references and context, and this is termed as pragmatics in the NLP world. So my initial query is find large earthquakes near California. Consider a subsequent query, how about near Texas? As part of this conversational flow, the semantics of a particular query can be influenced by each other via transitional probabilities. There are multiple probable paths. Here, a finite state machine shows the various alternative states for the query. Attributes from the previous state, such as large and earthquakes, are all augmented to the given query, giving a higher product of their corresponding transitional probabilities in this finite state machine, leading to showing large earthquakes for Texas in the visualization. Natural language queries can inherently be ambiguous due to syntactic and semantic variations between the user's mental model and the system's model. We expose the ambiguity and enable the user to correct default choices through simple widgets provided in the interface. Consider this query. Ambiguity for large is expressed as a slider widget set to a minimum magnitude of 5. Similarly, an ambiguity widget is expressed for a fuzzy distance near, which is initially set to 100 miles around the center of California, automatically computed based on the density of points per unit area. We also support syntactic ambiguity resulting from spelling and plurality variations and typos. So here the system maps happy to two attributes, happy life years and happy planet index, ranked by fuzzy distance measure. Once the query is processed, the analytics module determines the type of analytical function that needs to be invoked to show the results in the interactive visualization. We support various forms of analytical functions, including descriptive statistics such as minimum, maximum, average, highlighting, and color encoding. In addition to these basic functions, we devoted additional attention to special cases of spatial and temporal analytics. Lastly, interaction is not restricted to language-based queries alone. We allow for direct manipulation for asking questions, such as this example, where the user selected a subset of points on the map and asked earthquakes with magnitude between 4 and 6 here. And with that, I will hand it off to Melanie to continue with the rest of the presentation.
Okay, thank you, Vidya. So along with developing our prototype technology for natural language interaction, we've also been trying in parallel to understand how users would want to use this technology in the first place and how it can be most helpful to them in exploring their data and having a conversation with it. And so what I'd like to spend my time describing is an example of the kind of evaluation study we've been doing to explore those directions, and then also some future directions where we're heading with our research. So I've been running a number of studies evaluating various versions of the Eviza prototype, and I'd just like to illustrate one of them to you to give a sense of the kinds of things we're finding and the ways in which we're assessing the usability and usefulness of this interaction approach. So in this particular evaluation, we compared the Eviza prototype to Tableau Desktop. Now, Tableau Desktop is a visual analytics tool put out by our company, and it uses a sort of drag and drop metaphor to allow people to explore their data. So they can drag pills onto various shelves in the interface to get different kinds of vizzes to explore their data. And our goal in making this comparison was twofold. First of all, we wanted feedback on the design of Eviza to understand how to improve that. And secondly, we wanted to understand when people would want to use natural language to interact with their data in the first place. And to assess that, we wanted to compare it to a different kind of interface modality, in this case, drag and drop. So when do people want to use natural language, and when would they prefer to use drag and drop? So we conducted an experiment where we had 12 participants come into the lab for 30 minutes each, and the participants evaluated both Tableau and Eviza, and they thought aloud as they completed a number of predefined tasks. Now, we didn't want to give them the tasks in a written sentence form because we didn't want them to just simply copy and paste that sentence into Eviza. So instead, we presented the tasks in a table-type form where we gave the target data we wanted them to reveal in the interface in various cells in the table. So for example, one task would be to find a viz that showed large earthquakes greater than magnitude 6 in California, and another task would be to show the largest earthquake anywhere in the map. So what did we find looking at natural language versus drag and drop? The first really promising thing we found was that natural language was overall quite a bit faster for completing these kinds of tasks. So that's really promising. Secondly, people found it very compelling to interact with their data this way. We got all kinds of positive comments about using natural language, like, pretty impressive. You just type in a question and get the answer. We also were able to explore the kinds of situations in which natural language was most helpful to our users. So one of these situations was when drag and drop required many clicks to complete a task. And an example of this in Tableau is creating a reference line. So the sequence of things you see here on the slide are the series of dialogues that you have to go through in order to create a reference line on your chart in Tableau. And so that's several clicks just to create one, and you can imagine if you had to create several reference lines, this could take a while. Whereas with natural language, you could just ask for the reference line in a single sentence. Another instance where it was really helpful was when people didn't know how to complete the task using the drag and drop interface. For example, if you're creating a complex filter or a calculation, people sometimes know how to express that in plain language, but they don't know how to express it in the mathematical terms that a calculation function expects. And so in that case, being able to just type it in is easier. A third place that's really useful is when you don't know where to find the control to do the thing that you need to do. So for example, the regression line function is a bit hidden away inside various menus in Tableau, and it was hard for people to find it. And the last category of cases where it was really useful was when people didn't know where in their data to look for the thing they were interested in. And an example in the data sets we used was trying to highlight South America. It turned out that in our data set, South America was a value within a field called subregion. And that's not very obvious that you would need to look in something called subregion to find South America. So it's much easier just to be able to type into Eviza, show me South America. Some other things that we learned in our studies were that handling ambiguity was a really critical aspect of the system. There were lots and lots of ambiguous queries that people typed into Eviza. If you take just one simple example of average temp in spring, there's at least 3 ways in which this query is ambiguous. AVG is a short form for the word average. Temp is a short form for the attribute related to temperature. And spring is a fuzzy measure of time. And so handling these kinds of cases was really critical to making the interaction fluid. People also appreciated those ambiguity widgets that would show up to allow them to correct their queries. So while this was a positive feature of our prototype, it's still limited in the ways that it supports ambiguity, and we're continuing our research in creating better support for colloquial language. For example, the version of Eviza that we tested here wasn't able to understand convert C to F as meaning Celsius to Fahrenheit, and it wasn't able to interpret country with the most people as being a reference to a population dimension. Another feature of our tool that was very heavily used was the autocomplete feature, and that's as you're typing, the suggestions will drop down in a drop-down box and you can pick there. This was heavily used by nearly all of the people in our study, and it helped in a number of different cases. First of all, it helped with words that are hard to spell. I, for one, can't spell the word Fahrenheit no matter how many times I type it in. And so being able to just start typing that word and then pick it is super helpful. It also helps when you want to type a long phrase. It's just kind of a bit of work to type out something like Rhode Island. If you can start typing it and then choose, that can be quicker. And thirdly, it helps to learn the system's language. So the system, while it tries to be general and expect queries phrased in different kinds of ways, still has some limitations in the phrasing that it expects. And so, for example, users in our study were able to figure out that they should type unit in when they wanted to, say, convert Celsius to Fahrenheit. Another feature of our tool that Vidya demonstrated was Pragmatics, and that's the idea that the system would remember things from past queries and carry them forward into your current query. And it turned out that we had some mixed reactions to this. So a couple of users found this extremely helpful. And one example is a task where they had to show the min and max values in May 2014. And one user commented that this was a great feature because she was able to break that task into pieces. First, she asked the system to display the time range, May 2014, and then she asked what are the high and low temperatures. So for her, that was fabulous. Another user, on the other hand, was surprised that some previous things hung around. So she had asked for the min and max, and then later asked for the average temperature, and was surprised that the min and max stayed on the screen. So in our current work, we are extending Eviza to explore a better algorithm to help us decide when we should remember the prior queries and when we should forget them, and how we can better deal with this kind of pragmatic language. Another future direction that we're heading in is to increase the general intelligence of our natural language tool. Now, people asked all kinds of interesting things of Eviza, and one of the things they tended to ask was for information that was not inherently in the data set, but is sort of general world knowledge. So, for example, in a data set showing data about countries over different years, someone wanted to know what happened during World War II. Well, World War II isn't a date that's encoded in our data, but it is something generally well known, and we should be able to go look that up on the web, find out when that occurred, and then show the data for that date range. We also want to extend Eviza to deal with domain-specific extrema values like coldest or hottest, and to be able to handle things like trends and other statistical functions so that you could ask, for example, what is the seasonal trend in my data? So where we're at with our research is that we published an academic paper on this work last fall. It can be downloaded at this URL. And with that, I'd like to turn the moderation back over to Bill, who will handle the Q&A, and thank you for your time.
Well, Vidya and Melanie, thanks for that excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a lot of questions that have come in during this presentation, and we'll do our best to get through all of the remaining. So during this Q&A session, I'll leave up this screen with contact information for Vidya and Melanie if you'd like to contact them following today's webinar. So let's get started. You know, the issue of ambiguity and pragmatics, I kind of get the definition in terms of what is natural in analysis, that is, tell me about the average or sort or give me nearest. But there are also probably elements of ambiguity and pragmatics that have to do with specific knowledge domains, like, well, you picked earthquakes, but it could just as easily be healthcare or another topic. How do you differentiate between those two elements of pragmatics and ambiguity, and how do you improve on that?
Thanks, Bill. Yes, that's a good question. This is Vidya here answering. So what we decided to do was support some basic knowledge that can be generalizable across all data sets, such as, units tend to be consistent, temporal ranges, and so forth. But Tableau is really looking at empowering users across all disciplines to go about doing analytics. So we are going to be running into issues where a customer or a user has something that's extremely domain specific. It could be specific types of terminology or abbreviations that are intrinsically tied to an industry such as healthcare. So the way we want to go about it is allowing the user the freedom to point a data source or a knowledge base that Eviza can load up. It's equivalent to loading up a data source in Tableau and allowing the user maybe for the first few types of queries where, she might say, MJK means something, and then the system will learn from that. And if I come back and ask a subsequent question using that abbreviation, the system already knows what that means. So yes, there's going to be an initial bootstrapping process where a user would have to point to a knowledge base or correct the system. But if we keep that experience delightful and we provide a means where with just a very minimal effort, a user can do that, but from then on, the system can actually take that information and support a range of queries, I think that would be a worthwhile investment.
Yeah, thank you. Thank you for that answer. Yes, I know that in IBM's Watson and Microsoft's Q&A that just entering the corpus of knowledge in their question answering machine can be quite a task, but I understand from your answer that if you limit that to the specific knowledge that relates to the data, that could be a much faster learning curve. Am I correct in that observation?
Yes.
Yeah.
Yes.
Okay. Thank you. And
yes,
when
and on top of that, if
Sure.
you don't have if it's a simpler thing where you don't have to load up a whole knowledge base, if it's just a single word, for example, that the system doesn't understand, you could correct it on the fly, right? You could explain to the system in an entry what that means, and then it could remember it in subsequent queries. So, for example, if I were to ask for UW in Seattle, that's the University of Washington, system might not understand that, but I could tell it that once, and then it could remember.
Yeah, terrific. Okay, thank you for that clarification. When we were looking at your demonstration, the audience wanted to know how much of what you were doing was based on the typed entry and how much was based on cursor movement. Was this purely NLP that we were looking at?
Yes.
Terrific.
Yeah, it was text-based queries that were entered in, and the system was just responding based on what was parsed.
Okay, thank you. And you must have some plans about moving this onto mobile and for voice commands?
Yes. So I think there's a lot of things that we want to get right, starting with a desktop, a computer. Just the pieces, the pragmatics piece and the ambiguity pieces, as Melanie highlighted in the latter part of the presentation, we want to make sure that that experience is delightful and the system can support those range of questions. So once we have a good handling of that in a desktop context, moving over to mobile and voice seems like a logical transition. One thing to make note of is on a mobile device, it's not just the modality of voice that's the difference. There's a lot of task specifics that are inherently unique to a mobile device. You're on the go. You might be touching the screen and pointing and gesturing a lot more than on a desktop computer. Pragmatics, the flavor of pragmatics could be even more different, where I might refer to previous queries using pronouns, how about this or how about that? So that's going to really open up a whole new set of research topics that are specific to mobile and voice. But we'd love to get to that point once we make that experience worthwhile on a desktop.
Terrific. And, when we see exciting prototype demonstrations, and I have to underline the fact that you said this was a prototype, we understand that this is still in development, but can you tell us what the rollout time frame is? Because there are lots of questions here about, wow, when can I get this?
Yes, we get that question a lot. Here at Tableau, we've really recognized the importance of providing analytics to the general masses, right? I mean, we want someone like a school teacher being able to ask questions about her students' data all the way to a sophisticated data scientist. And we do recognize that natural language could be an effective medium for supporting that. So that being said, we're really spending a lot of thoughtful effort and time in trying to just get that experience right. So we don't have a public timeline. It'll probably happen in a soon time frame, but we're more focused on just getting that experience rolled out thoughtfully and well so that it's of use to Tableau customers. So that's where we are.
Well, that's great. A lot of us can't wait. I hope you'll keep us posted. And I guess that leads naturally to the question of, when you thought of doing this, was there a particular category of customer that you were targeting? Is this the beginner or the advanced, or what characterizes who you think will use the NLP feature in Tableau?
So I think that it can support quite a variety of different users, but I think it has a special value for the novice user, the person who doesn't know how to create the calculation that's, kind of a complicated action in Tableau, or the person who only interacts with published dashboards and never actually opens the authoring product. So they can currently only answer the kinds of questions that the dashboard author has enabled them to answer through the dashboard design. And so natural language is maybe an intuitive and easy way for them to be able to explore their data a little more deeply and answer some of the questions that they have in their mind that they don't necessarily know how to express in mathematical language. So that kind of person is our initial target for the NLP feature, although it certainly can have value even for the expert in just speeding up some of their tasks that might take multiple steps using standard drag and drop kind of interfaces.
Right. So tell me a little bit about how you think this will be integrated into the Tableau product. Will it be a separate product, or will it simply be an option on the top line?
I think that we can't comment on that right now because we're still figuring out what is the best way to roll this out in our product. We're definitely exploring a variety of options and considering how NL interaction can provide the best value to our users, but we haven't made any specific public announcements about where in the product line it will fit.
Okay. Now, the audience had a bunch of very specific questions about what they saw, and let me just kind of run down them here and let you respond to them. For example, does Eviza automatically pick the chart type on which to display the best representation of your query?
Yes. So what we did was we took the logic that Tableau uses for Show Me. If you're familiar with the Show Me feature in Tableau, it's a rule-based feature that looks at the types of data attributes. You know, how many of these are numerical, how many of these are categorical, and comes up with a plausible candidate for a chart. So we simply adopted a subset of those rules to show a chart. Now, that brings up an interesting point where, you know, the choice of chart itself can be ambiguous. So one future work that we're looking at is if Eviza, for instance, shows a bar chart, as a user, I might say, well, actually, it's as a scatter plot, or take this bar chart and split it into a small multiple. So there are some interesting nuances in terms of how a user would, you know, ask a follow-up repair utterance, as we call it, to update the result or the visualization itself.
Okay, terrific. Thank you. Now, let me talk a little bit or ask a question a little bit about drilling down and granularity. It seems to me that the granularity of the analysis is obviously limited to whatever's in the data, but talk a little bit about how we would, from a higher level screen, get down into more granular analysis. And we had one audience member say, gee, could this tell the difference between a McDonald's in one city and an In-N-Out burger in another city?
So I think there's a couple different questions there. The one around drilling in and out, I can see a couple of ways in which we might do that. So, for example, in Tableau already, we have a notion of some hierarchical fields, like time, for example, can be broken down into year, which is above quarter, which is above month, and so on, all the way down to seconds. And people can drill in and out of that time hierarchy already in Tableau dashboards by using mouse interactions. And so we could simply extend that functionality to natural language interactions, where people could say things like, show me this at the month level, or drill in 2 minutes, or roll this back up to the year level. So we could enable that kind of drill in and out functionality quite easily. And then in parallel with that, the way Vidya demonstrated creating new charts, you could imagine doing that to show the data at different levels of detail. So maybe at the top level of detail, I want to see just a map of earthquakes grouped by what state they're in and which states are the most, that have the most earthquakes or the highest level of earthquakes. And then maybe at a level down, I might ask Eviza to show me all the individual earthquakes in a given state. And it could produce me a new chart that shows me the dot map of those. And then I could produce more charts to show perhaps the timeline and so on.
Okay, terrific. Terrific. And what about the question of the differentiating specific retail locations by brand?
So I'm not sure quite what you're getting at there. I think we would have to go with what's in the data. So if the data for, say, if the data showed In-N-Out Burger in California and McDonald's in Nebraska, if I asked for McDonald's, I'm naturally going to get data around Nebraska, and In-N-Out Burger, I'm naturally going to get California. We just simply sort of search our data based on the records that we have. Right.
That makes perfect sense. Thank you. let's see. Many of the questions that have come in from the audience have to do with the broad area of natural language processing, particularly spoken words, and how you handle that in the broader context, pretty much aside from Eviza. For example, as natural language processing scientists, how do you deal with, for example, different hard to understand accents or misspellings?
Yes. So misspellings, from a text standpoint, there's a lot of research that looks at spelling variations or even just patterns of mistakes that people might do. So the nice thing is, as we roll out this feature, we can get behavioral patterns in terms of, what are the most common ways and variations that people would ask questions. And the system can learn from that over time as users correct and tell the system, this is actually what I meant. Now with voice, it opens up a whole new set of challenges, including accents and intonations and background noise. But given that, the promising thing is there's a lot of research that's working and is continuously being developed. I mean, we've seen Amazon's Alexa, Google Home, and they're getting better and better. So my hope is we can leverage some of those APIs. I'm not trying to say we'll use one or the other, but in general, this whole space of solved problems in the voice API space that we can take advantage of and add additional layers of enrichment and pragmatics that are scoped down to data visualization.
Yeah, it's such a huge area with so many challenges that are just emerging, and I think you've got many years of good work ahead of you, just trying to figure out the answer to some of these basic questions. We didn't ask the question about your plans for foreign languages. I've got to assume that's in the plan.
Yes, I mean, as we all know, Tableau does support several languages, so it just seems logical that we would support any of those when we roll out the feature. But we're trying to figure out some of the key NLP pieces using U.S. English as the starting language and then working our way from there. There are going to be some commonalities across language just in terms of the user experience and how we handle ambiguity, but there are going to be some inherent differences too, because different languages have different sentence structures and how they interpret nouns and verbs, and pragmatics can be kind of different across languages. So we'll have to take those into account. And when that time comes, we will probably work with teams that are specifically skilled at those localization issues.
Terrific. Hey, and Vidya, Melanie, thanks for some great answers to some very good questions. I know on behalf of the audience, we all want to say, boy, hope you hurry up and get this to us. It looks really terrific. For those of you that asked questions that weren't answered today, we'll be sending all the unanswered questions to Vidya and Melanie and the Tableau team so they can follow up with you after today's webinar. Now, I have just a few quick announcements. So if you'd please mark your calendars for February 7th, and that's our next DSC webinar, which will be Improving Advanced Data Prep and Analytics in Spreadsheets, to be presented by Alteryx. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. So this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Tableau for their sponsorship, and our speakers today, Vidya Setlur and Melanie Tory, for their insights into today's topic. Now, my name is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on February 7th. Have a great day.
Thank you.